So hello, everyone. Happy New Year. We're going to go ahead and get things kicked off again for the API work stream. For today's discussion topic, we've had a thread that's been going on over the past couple of weeks around the architecture, and essentially it's really focused on we need to start thinking about not just how the API for configuration works, but also what the pipeline implementation looks like. And if you haven't taken a look at it, there's actually an entire thread topic that's out there that is located. I'm going to place it in the chat at this location. So it's part of the list messages. It also, this is something that'll be captured. It's not something that times out like it would inside the Slack channel. At this point, I'm going to open the floor for any discussion or comments around architecture and where we need to take it. I know Elko, you had started this thread. Vipin's joined in. We've had several different inputs to the thread, so I'll open the floor for any discussion around this.
Yeah, can you guys hear me? I'm not sure, my setup is not working very well with Zoom these days, but
yep.
Okay, cool. Yeah, so I started this thread like I think late last year when I was about to go on PTO because I was trying to follow what's going on with the API. And to me, it felt like that we were trying to define an API before really knowing what the architecture looks like. So that's what I tried to raise in the email, that it looks like we're trying to do sort of a per use case API and then see where we end up, which I thought was maybe the wrong order, because I think it makes more sense to find, sort of the building blocks. So let's say the architecture, and then base the API on top of that. And then when I was reading through some of the documentation, trying to understand it, there are mentionings of using OpenConfig, which I thought was a really good idea in the sense that at least it has a defined model of how your pipeline or however you want to call it, your architecture looks like. And then that will be like a general thing. And then from there, you can define your API. But yeah, that's what I tried to express in the email. But maybe it didn't really came through correctly.
No, I think it came through fairly well. There's been a lot of comments back and forth on it. We've been looking at kind of two sides of the approach. One of them is to look at more of a configuration type aspect of it, and then of course you have separately the pipeline. So we're looking at it from those two aspects. From the pipeline perspective, we have to set up the different elements, configure them so that the data path would work, and then go up to the VFPF interface. Whereas for configuration, we have to know what those elements are that we're configuring and setting up within the system, which may be additional functions that are being placed in or whatever. I know that Prasoon has volunteered, at least from the inputs that Joe put into the thread. Prasoon had volunteered to take a look at updating the current thread that was out there, current flow diagram. But there are lots of other flows that we have to consider in terms of putting that into the overall architecture and then starting to map out the architecture for both configuration as well as for the data pipelines.
I feel a little bit that we're going a little bit back in time, because for the past several meetings for the API committee, Vipin presented his view that we cannot come up with a single architecture. There is impossible. And if anybody can come up with a single architecture that can answer all the use cases, it's perfect. but we feel that this is kind of a huge task and we shouldn't proceed this direction. This is why we switched from the general all accompanying use cases to more focused on the specific use case. And once we develop the use cases, if we find a common elements, if we find there is eventually one answer to all the use cases, that would be a perfect answer, but we just don't believe this is the way things are. This is why you see the approach was taken for the more use case driven approach. And the first use cases, which is AMD Pensando contributed as a pull request, was identified as a cloud use case, which is in production APIs for AMD Pensando. So those are not theoretical APIs. Those are actually taken from the production deployments with some of the big cloud providers. This is how they operate. And we want to adopt this model with modifications to accommodate all the different DPU companies, not be specific to AMD Pensando. And this is the first use case we found. If going forward, we can locate more use cases and we see a lot of similarities, for sure, we'll restructure APIs to have more generic building blocks.
Well,
but I think,
maybe we could have a middle ground there. So Christophe Fontaine, I'm part of Red Hat. I'm extremely new to the project. I didn't have contributed, but I was thinking that we may have a specific requirement with two different endpoints towards the same API. One public API towards the workload, where the workload could request its network, because I really want to have a network connection towards that specific network with that UID, and that could be a very small subset of the more global API, and an internal API that would be configured by the network administrator in order to configure the different network policies as well. So maybe we do have two sets of APIs, or even eventually a single set of API, but with a different RBAC. But that way we could at least define the common API towards the workload.
Yeah, I think we're going way too fast. Like already saying that we cannot have a common API. What was that based on anything? I mean, did we have two use cases? Did we compare it and came to the conclusion we cannot have a common API for those two use cases or a common data path? I mean, just looking at the open config, for example, it might not be the best way, but looking at open config, can you come up with a pipeline that will fit two use cases? I'm trying to say that.
Elko, you're looking at open config as a finished product. We are working.
No. I'm not looking at open config. I'm looking at the concept. So I'm looking at the concept where you can define your whatever Yang model, and that will be your pipeline or your feature or whatever you want to call it. Why did we say that we cannot have a common API to describe what we're trying to do?
so
we
why
can
do
go
we-
back. We can
So-
go back to the recordings that Vipin did that explaining why we cannot come up with a single APIs. And I think there are two approaches. First of all, first approach is let's stop everything, go back, rethink what we did, come up with 10 use cases or 2, whatever, let's exaggerate for 10. And let's try to find a common API that covers all the use cases. I assure you, we will not produce anything eventually if we go this direction. The other approach is more practical one. Let's take one use case, implement it, come up with the second use cases and change the APIs to accommodate 2, 3, 4. Then at least we can produce something. You saying we're moving too fast, I say we're moving too slow. We are 1 year in this project. We have very good established storage APIs. We are absolutely behind on the network APIs, and companies losing confidence if we are not going to produce any APIs. So the approach that I think more practical, maybe not the best, but maybe just to move us along from this stale point that we are, is to move forward with the single use cases that we have in our hands and solve it and vote for APIs and say APIs, implement those and make sure they work correctly. And then if we have 2-3 more use cases, we can always go back and restructure. Those APIs are all alpha, beta, whatever you feel they are. And we can find common blocks, we can refactor everything. But if we are going to stop and try to solve all the use cases or come up, maybe we'll end up with a single API. I'm not saying we are not. I'm just saying maybe iterative approach, baby steps is what will actually move this project along.
Yeah, so let me step in here for a second. I think, you know, as Boris was saying, it's an approach that we've adopted going forward. We are not trying to not go after a common API. You know, I know I used 2 knots in that statement, but the goal is to come up with a common API. We realize that as we do this, we're going to have to look at things on a use case by use case basis. And again, we don't have all of those defined yet. There are various use cases that are coming in from customers. The use case group is working on various ones that are inputting to this. So, but right now, the use case that we have that's in place is a cloud-based one. We've also identified that we need to go back and take a look at SDN use case. We need to look at an enterprise use case. These are things that we're going to have to iterate our way through. We're going to have to look at layer 1 PR type settings. So we need to create a layer 1 pull request around that. We need to look at layer 2 settings. We need to look at static routing as some of the capabilities. But again, we can leverage from OpenConfig. We can leverage from other standards that are out there. The complexity with the networking that we have found is that there are multiple ways of doing the configuration. You can look at OVSDB, you can look at OpenConfig, you can look at various others, VPP, etc. So we've got lots of different ways of configuring, and we want to try to make this a common approach, come up with a common framework, but we realize there's going to be probably some extensions that would be more, this one's more cloud specific, or this one's more enterprise specific, and it wouldn't apply to cloud-based use cases. It wouldn't, and similarly, enterprise stuff wouldn't apply to enterprise-based use cases. So that's kind of the approach that we've been taking, and just to explain it. And does that help some, Elko, in terms of clarifying?
Yeah, it definitely clarifies it. But the problem I'm still having is that we are defining APIs, and we're not defining the way the packets are handled. So what I think would be an approach, but I'm not an expert on Yang, but if we would have a Yang model that basically explains what we're trying to do, so we connect the different blocks up with a Yang model, then we can extend and it becomes fully dynamic, and we can change whatever we like. We are not tied into a very fixed set of APIs, as the Yang model allows you to dynamically change stuff, and it's easier to adopt. Whereas if you have, currently we just define protobufs, and then we assume that, you know, whatever architecture was defined is all behaving in the same way on every hardware vendor supporting it.
And perhaps we can approach that in a parallel. We can do that in parallel to the same efforts that are going forward, and then kind of bring those together as we move forward. We don't want to stop the forward momentum, but we also need to take into account the architecture, which has come up through the thread discussion. We have to take into account the pipelines, which has come up through that thread discussion. But we also need to make progress so that we can continue to move the community forward.
Yeah, so I think there was different definitions for the same thing, or maybe different definitions for other things. But I think pipeline, so let's say pipeline is more based on how you would implement it actually in your DPU. I think that was an outcome of that conversation. So that's fine. So from an OPI perspective, we don't really care about the pipeline, but we do care about the architecture. And I think the architecture and the API can be put into a Yang model, and then both of them can be extracted from there. I have not much experience in that, but I think that should be possible.
Okay. Thoughts, anyone?
Well,
Yeah,
I'm really in favor of OpenConfig or any kind of network intent, because as soon as we're talking about the API and from the API, it says, hey, I want to create that tunnel with that parameter and so on and so forth. It really limits the different capabilities. Whereas with Young model, we can directly extend, and from a basic set of functionalities and that could be defined by Young model, maybe that could be only a subset of OpenConfig to be compliant with OPI alpha, and then we would have extension to that Young model in order to accommodate every single specific use case. And that way, within those extensions, we could also expose the hardware capabilities, which would be specific to each hardware vendor.
All right. Prasad, I saw you go off, and I apologize. You're the one who volunteered to do the work related to that, not
so maybe first question first, right? So obviously the diagram that I had created provides a certain level of detail. It may not match the imagination that others have, but I think it allows dialogue that says, yeah, this is what I was imagining versus this is not what I was imagining. So maybe the first question I have is for Eelco to say, okay, so the architecture that you have in mind, I'm still fuzzy on what different detail is it going to provide than a pipeline diagram. We can describe it in English and text, but the clarity that you seek perhaps is still the same. As a vendor, I need that clarity.
Yeah, so I think that is what the Yang model will give you, right? It tells you exactly how your packets will flow. It will generate the pipeline for you if you define the individual elements.
Well, that's where the Young model can only provide you the network topology, for instance. It will not define how you implement that network topology.
Right.
But I think that's even better to hide this kind of details of implementations towards the workloads, because at the end of the day, we don't care whether that's flow-based or not flow-based, whether that's Open vSwitch or VPP, or at least we shouldn't care on what is actually running on the DPU. But from a workload perspective, we want to specify the network connectivity, or at least to request to have that specific network connectivity, eventually to expose that floating IP and through BGP and so on and so forth, but that would be attached to the network and to the router instance defined in the Young model, where we could extend the router with dynamic routing and so on and so forth.
Can we share maybe the demo topology and the specific use case in case, if you allow me, I'll share. This is from the link that I shared with you. I think this is a good start, and I'm just asking the group, why don't we start here? This is a presentation that Keysight did together with AMD Pensando. This is the topology that they built. They hide completely the implementation, what DPU does. Specifically for AMD Pensando, they do in P4 pipeline, but it's not important. The APIs that we're using, I'll show you in a second, but this is just reiterating what we did, Urse and Vipin presented last time. So this is Keysight environment. We see the topology here. We see the routing. We see the IP addresses. Those are the APIs that we said are participating currently. This is a stack, like we do in the VXLAN tunneling, ACLs, routing. We said we are missing layer 1, layer 2 connectivity as well here. And the APIs that we are currently building, and again, Young model, OpenConfig, this is all implementation details that, if I remember correctly, OpenConfig is based on GNMI, which is also gRPC. But still, if we're building gRPC APIs, whether using OpenConfig or YAML models to define the models themselves, but this is the things that we want to configure. Am I missing anything? Like why this is?
So yeah, but I think the difference is if you define a YAML model, you also define how the interfaces are hooked up to each other, how you have your routing domains connected to a layer 2 switch. So it becomes a bit more dynamic on what is input and what is output. So then if you need to make a change, you can still change that in the YAML model. And then whenever you get the YAML model as an API or the gRPC API, you know which elements you have to connect. And then you can do that on your DPU side on whatever is your best approach to set that up.
So YAML model is being generated, is generating what, gRPC APIs?
I think you can
No,
do that. I think
and data
that's what
structure.
OpenConfig does, right? Yeah, and data structures.
With Yang, you only define the data structure and an additional set of, well, APIs with mainly netconf or restconf, but basically it's just an access towards a data store. So you do not define how you, what is the actual pipeline, but rather you define the topology. And that's very similar to TR69 or SNMP in that sense.
Vipian, you want to comment how this is different from gRPC APIs that we're building?
No, I think the request that Elko has is valid. That we need to link these objects and interfaces. So I'm 100% agreeing that we need to define that. I was proposing in the email that we could define it either in a document, which is then backed up by the test APIs, because ultimately test suites are going to cover whether you're doing the right thing or not compared to compliance with APIs. Or if we define it in in a model where we say that, okay, the first thing that's going to happen to a packet is interface lookup, and after interface derivation, you're going to do some level of tenant identification. After that, you're going to do maybe a layer 2 bridge lookup, and then routing lookup, then tunneling decap, and then all that, all that things. So I was assuming that, of course, the goal of 128 was to give a glimpse of how the APIs will look like and not document that detail itself. Of course, it's in my mind, it's very clear how that detail looks like. I'm happy to document that against the APIs I proposed. But if someone wants to take that and define that in either YAML model or some other way, I don't think it's misaligned with what we have been saying so far. I feel that it is complementary and we should do both. I don't believe it will be a big surprise to a cloud user as to how these things need to interconnect. For example, if we were to say that, in cloud use case, you always derive, the workloads identification based on the VF or PF first. The difference that Elko I was saying why these things cannot be combined is not because you cannot come up with one model which does everything under the sun. You can. The question is who's going to implement it, because ultimately the resources are limited. And as a hardware vendor, I could say that I want to use the resources to the best of what is needed for a given use case. But if the model defines like, A feeds into B, B feeds into C, C feeds into D, and for cloud, I don't need B and D, but hey, well, I need a way to skip it. I need to model it in data path or something equivalent. That's where I was saying that, defining one thing is going to be okay, but implementation wise, it'll become challenging because ultimately resources are going to be limited, and trying to have unwanted things will show up. And in the previous meetings, I was demonstrating that, the reason the OpenConfig and some of the things were developed was to configure a switch. Now, configuring a switch is very different from configuring a NIC. From networking, it looks like, yeah, what's the big deal? It's all routing, it's all tunneling, so what? And interfaces, right? Yes, there is common elements. I'm not denying that. But the moment you get into details of how stateful functions work versus not, and what kind of what levels of tunneling you need in switching versus on the cards, and those things will differ, and then people start like saying that, oh, only if I could eliminate this step and that step, I could use my resources really, really well. Because most of the vendors have like n number of lookups that could be chained together in data path. Maybe it's 30, maybe it's 50, but you don't have limitless software view of this thing to be implemented in data path. And ultimately, if there is no performance, no one's going to look at the DPU seriously, because ultimately you will suffer that. Anyway, I didn't mean to sidetrack. The main comment I had was that we should define the interlinking of these objects. Absolutely, we should, and we should find out how we define it. I'm fine either way. If you want to define it in Yang, if you want to define it in a doc, which is then backed up by APIs, or like I was showing, appliance implementation in Dash community, they have defined it in P4. It is very clear. It's as crisp as you can get. There is no room for any misinterpretation at all. And they have been doing fine. I think as a community, they are thriving and the definitions are proceeding quite well. So we can pick one way of defining this interlinking. And even though people think P4 is a very low level thing, actually it is not. It is defining what table lookups happen, which order, and they are fairly high level. Unlike flow level things. For example, people talk about what headers to parse, what feeds into what lookups and all that. But anyways, I think that's my thought. Boris, I don't know if it answers the question.
I'm trying to understand the difference between going with raw gRPC APIs that proposed here, Elko and Christoph, versus defining that in Yang model, and then Yang will compile them back to the raw gRPC APIs anyways. We can always do.
My take is that, from what I understood, Yang model could also define the interrelationship between these objects. Like, for example, if you have tunneling object and you have routing object, which happens first? Routing or tunneling? Well, in this case, both, because you have to do routing on the outer, then terminate the tunnel, then do routing on the inner. I am assuming that this kind of relationship could be more precisely captured in some way. I'm not saying it has to be Yang. I'm just saying that in some way. If Yang is the one that we all agree to capture that, that subtlety, then let's go with that. But ultimately, we need to have some way of having that relationship. And I think this was also a comment on 128, by the way, Boris, if you recall, people have been saying like, can we put a picture to these APIs? And I was like, I'm more than willing to. It's just that, do we want to go this route? Because I think there has been confusion whether we want to even pick this route or not. And that's why I did not. But absolutely, I've been always wanting to do it, as long as we want to go in that direction as to what is the relationship between these objects and how, because that is going to form up the definition of it. And if someone who's writing APIs can then say that, yeah, I have written the test APIs to it, and it works because here's the spec, and here is how they are implementing these APIs. And now I could say that yes, it implements exactly what is specified in the specification, for example.
Yeah, you're absolutely right, Vipin. With Yang models, you can definitely define the different relationship between those objects. And that whole purpose, because we can completely define and describe the complete network topology at multi-levels. And that's why I think Yang models is extremely well suited for that, because it will also hide the different complexity underneath that could be exposed with P4. Because as soon as we're talking about P4, we're already thinking about a specific pipeline or data model. Whereas with Yang, because you're describing the high-level network topology and the different relationship between those objects, I think it would be a bit more clean.
We're not talking about P4, Christoph.
Yeah, but
either we do in Yang, as you say, or we do gRPC APIs. In both cases, implementation is completely hidden.
So Boris, if I were to take the storage API just to orient ourselves in the right way, the way we define inter-object relationships is using the handles that refer to each other. That is kind of implicitly defined in the gRPC APIs. For example, if you have a namespace object that refers to let's say if that refers to controller, then it has a handle which then refers to the key of the handle. So there is that way that you have defined the relationship between objects inherently in the APIs.
No, I understand. I understand.
And so do we want to go more explicit, or is this sufficient enough for someone?
I believe it would be better to be extremely specific thanks to young models, because after that, you can have your own validation tool based on the models, so that you can provide some hints to the end user to say, okay, this hardware is not capable of doing that because we are exceeding the hardware capabilities.
Yeah, I understand. So basically what you're saying, Christoph, is let's take the YARN model, and it will bring us exactly the same gRPC APIs that Vipin defined, plus the relationship between them. Somebody needs to contribute that, right? We cannot continue and just talk about it. Vipin did a very good thing by just contributing the protobuf definitions. If you or somebody else willing to take their time and define those YARN models, for sure, we are very welcome in that. And then show us the compilation, how this is compiled to the gRPC or GNMI APIs. And then we can have a, like we discussed on previous meetings, we can have a DPDK-based reference implementation that implements those APIs. So we can show the networking topology for specific use case, like I showed previously on the demo topology. We show the routing and the tunneling and all the different other things from the networking perspective. Does it make sense?
Definitely makes sense. And yeah, as you said, all the virtual switch such as VPP already have their own young models exposed, which do not conform to that open config. So this will require a bit of work in order to do the proper implementation based on open config and then to provide that. But
are you going to take this and move it forward? Because again, we can discuss this indefinitely in these meetings and say we take in the wrong direction, but somebody needs to step up. There is no workforce except for people that are on this call. Somebody needs to go and write the YARN models.
well, because
Vipin wrote his protobuf definitions and contributed to OPI. We have that, and we can build the reference implementation together based on those APIs. If you or somebody else can define the YARN model, and we can compile it to a proper language, and we can have a reference implementation out of that, absolutely, let's do that for sure. But until somebody volunteers, we cannot continue and just in void continue discussing this without moving forward. Make sense?
makes sense.
Boris, can I ask a question regarding the image that you shared? You shared an image with the DPU and talking with the SDM controller.
Sure.
I'm just having like, I want to understand how this demo topology plays together with the conventional SDN approach, where we have the network, we have the southbound API, for example, OpenFlow. We have the SDN application, for example, in Kubernetes, we have OVM Kubernetes, and we have northbound API. And I just trying to, the use cases that I think about are networking, security, visibility in Kubernetes. And I'm trying to understand how OPI is different to conventional SDN approach. And another question is, I listened for several meetings and you keep saying DPU, but I'm trying to understand what is the difference between DPU and SmartNIC per your understand how you see it. Okay, did my question was clear?
Yeah, so because Vipin and Mircea from Keysight did the presentation, so I can share my screen so everybody can see the PDF, or Mircea, if you want to share, and you can answer Naftali's question. Vipin and Mircea.
If you have it ready, it's okay if you share, so I don't spend time finding it again.
I have it ready. I also posted the link in the chat so people can, switch between slides. Yeah, go ahead.
Okay, so like fair question for me. Remember the context for me is a Kubernetes OpenShift, and in Kubernetes OpenShift we have the SDN controller, we have the SDN application that communicates with the end controller with northbound API, and the SDN controller, like the northbound API tells SDN application tells the SDN controller through the northbound API the networking intent, and then the SDN controller transforms the networking intent to the actual, I believe what you say, pipeline behavior with southbound API, which is OpenFlow. So first question is how this OPI thing fits in the traditional SDN model I described, and like if we're talking about DPU, for how I see DPU, there is a difference between a DPU and a smart NIC, and the difference.
So let me start with answering, and then Vipin and Mircea can take it. So first of all, this use case is not described in Kubernetes environment, right? If you remember, we started to focus on cloud providers. So from cloud providers perspective, there is the end controller is talking, as you see here, using OPI APIs to the DPU and defining all the routing, overlay and underlay, all of that stuff. Saying that, we started to think about Kubernetes as the end controllers as well, and started to think how that can fit into the same model as well as a cloud. So there are two topics that potentially, hopefully, can bring the same answer to both use cases. But just to make sure, this presentation here is not focusing on Kubernetes, but Kubernetes is always in our mind, and we already started the conversation there. So I'll let Vipin and Mircea maybe answer your questions more.
Actually, like the OPI API, I didn't know that there is something that exists, but for example, OpenFlow, it's something that exists, I believe, more than 10 years. So I'm trying to understand, like, you say cloud providers using OPI API. It's just not clear to me. You understand?
Vipin, you wanna take this?
Yeah, I'll take that one. Mircea, feel free to chime in if you have any comments.
Sure.
I think it goes back to that, can we envision one SDN controller for everything that the DPUs will be used for? And my argument was no. This was like about 2 months ago. An SDN controller that controls 5G UPF pipeline is not going to look like what it controls for a tenant's networking for Kubernetes, and it's not going to look like same as an SDN controller that wants to control infrastructure for a cloud provider. And therefore, I think trying to say that one API can serve all SDN controllers is a bit of a stretch at best. I mean, it's not something we can do. The world has already moved on in those directions in their own situations. They have their own controllers. You can't go and ask a cloud provider to use Oven or something like that. They have it in production, whatever they use, and they're not going to move to this because OPI API is looking so attractive to them. So instead, the assumption to your point is that, what Boris was also saying is that instead of trying to come up with one that could serve Kubernetes and that could serve cloud infrastructure and that could serve 5G, why don't we assume that like PFCP APIs from 5G is not going to use Kubernetes APIs, and let's just part our ways and try to define one thing well. So if the question is that, how is OVS or how is Kubernetes data path going to look like? Because Kubernetes data path also, we had plenty of discussions. There are like 4 Kubernetes data paths today. Cilium uses something else. OpenShift uses something else, which is OVS based, and Calico uses something else. These are popular CNIs. I'm not talking about something which is like it's like 30% share minimum that I'm talking about from the CNI point of view. So which Kubernetes CNI you're talking about? I assume you're talking about OVS-based CNI, which is probably OpenShift CNI or something equivalent. If we go into OVS-based CNI for Kubernetes, then yes, the controller is going to talk OVS DB southbound, or if it is Avan southbound DB from the controller, and that will create an OVS DB bridge and OVS DB related related functions, and eventually it'll program OpenFlow southbound to the DPU. If we were to implement that, this API is not a good fit. I wouldn't mince any words here and try and force this API into that use case, because it won't work. If we want to talk about Kubernetes use case, we had extensive discussion on Kubernetes use case. We put up a question like, which CNI do we want to accelerate? Because all CNIs use different APIs. We can pick one, or we can pick two, and we can go with that. Or we can pick one which is going to be more accelerating friendly and go with that. And we did discuss that also, which ones are more acceleration friendly versus the rest. I think Intel produced something where they were able to accelerate Calico APIs. We all know that OVS can be offloaded. We kind of punted the eBPF discussion on Cilium completely and say, well, we'll look at it later. So if we pick one of the two and we start looking at that API, that picture will look different from this one. I'm not going to say that it is the same thing. And which is why I think, at least in my mind, I came to the conclusion that instead of trying to unify the world here on DPUs, the world which has already moved on to their own APIs and their own controllers and their own way of managing the data path, let's try and create DPU value in their worlds rather than try to have everyone use our version of one OPI API for all domains.
But correct me if I'm wrong, Vipin, the picture is not going to look different, as you said. The picture is going to look the same, but the OPI API will be OPI API tag, OPI API 2 tags, OPI API 3 tags, different OPI APIs, but the picture is the same.
Definitely.
SDL controller is going to talk.
Definitely. Boris, you are absolutely correct, because we as DPU vendors don't want 4 APIs for 4 things. We want to just create one APIs, and Kubernetes world can use that API from any DPU vendor. Or cloud infra providers can use one API from all DPU vendors. The main goal here is to have all DPU vendors also align, so that we don't have to do different things for different. We already have to do different things for different use cases. I don't think we are going to be able to move those use cases and reconcile these worlds just because we are all together as DPU vendors here, or we are all together trying to define some API which is common. So if you want to take that charter, amen, go for it. I don't think it's going to be as easy at all. And these things have been gyrating on their own axis for at least 10 years. And some of them have been around for that long, and there have been ecosystem that has been built around. There's no way we could change that, and we should not, because there is already existing brownfield software around it. So yes, the OPI API will have a different version, but the layer we want to cut it is roughly at that layer, if at all possible. But we need to have more discussions, Boris, to come up with a cleaner version of an API that could satisfy those use cases. And frankly, we have not had deeper discussion on any. I presented one for the cloud, but I don't know whether someone has presented one for the others. I saw one for Kubernetes, but that was
from Intel, yeah.
IPDK repo from Intel on how a gRPC API could
specifically
look like.
With Calico, yeah.
Correct, with Calico, yeah. So that's the closest I saw. I mean, if you want to adopt that, and
Naftali, that makes sense. You have maybe more clarification questions we can answer.
Like I thought that OPI, like the main goal of OPI is to take the DPU, all of them, and to abstract them. But if you're saying that, okay, Kubernetes, it's not fitting our model, so like I'm trying to understand, okay, so
no, we're not saying that. We do want to abstract, but per use case. Probably is going to be a different abstraction for cloud vendors across all DPU vendors, and different abstraction to Kubernetes across all the DPU vendors.
Mhm.
This is what we're trying to say, probably.
But they may have common aspects that are across all of
Yeah.
those different solutions.
And yes, I think that's where we were saying that we are not even close to an idea that there are going to be common blocks that we want to keep it together and try and streamline things. Absolutely, we want to, but we don't want to start with that as a primary thing because we don't know what we don't know, and therefore.
But yes, the commonality. Correct me, Vipin, if I'm wrong. But yes, the commonality across all the DPU vendors for the specific use case.
Yeah, there is that commonality, and if there is a commonality between different use cases too, we want to definitely not reinvent the wheel there either. But at least from my experience of having touched different use cases, I feel that there may be common elements, but since the controllers are not going to be common and use cases wise, it's not that 5G controller would want to certainly, use something else, for example, like UPF versus cloud infra. But anyway, I think, I don't want to proclaim that it is never going to be there. I wish there was one, to be honest, but unfortunately, it's not as the way I see it.
Naftali, does it make sense? Any more clarification questions?
And one more thing, it's a bit more philosophical question, actually. All the what you're saying, for me, it fits the smart NIC idea, and I'm just trying to understand, like, where is the jump to the DPU? Because for me, the biggest difference between a smart NIC and a DPU is compute capabilities of a DPU. And like every use case you talked about, I followed for several meetings already. It seems like you're more focused on the smart NIC approach. Am I wrong?
You probably, am I trying to understand what you're saying more concretely is, for example, Red Hat demonstrated putting SDN controller inside the DPU that utilizes the DPU compute power. So maybe this is what you hinted at, for example?
Actually, what I'm hinting is, for example, again, I'm going again back to the world of Kubernetes. For example, in Kubernetes, you have the user workload and you have the infrastructure workload. And for example, you want to provide security, you want to provide visibility, telemetry, and things like that. And like my vision to the DPU, you take all of these things that are not user workloads and you offload them to the DPU. But yeah,
absolutely, and that's exactly why I'm a proponent of that young data store, because by definition you can extend those young models with additional functionality. So this means that the additional software function that would be deployed on the DPUs could also extend and expose their own young models to the central young database, so that the workload can configure those network functions.
Just wanted to share, sorry for interrupting. Yep. Just wanted to share this blog from Red Hat. So maybe this will clarify Naftali's question a little bit, right? So here, for example, we see the OpenShift worker node, and we have OVN Kubernetes that's running in the host mode, and we have OVN Kubernetes running in the DPU. And they are communicating between each other. This is actually using the OVN, the compute power of the DPU versus the smart NIC.
I'm familiar with this approach, but this approach is, for me, is smart NIC as well, because in this approach, I believe NVIDIA and Red Hat, they did not allow actual real workloads to be run on the DPU node. The only thing you're running on the DPU is you offload the OVS and maybe accelerate it, but
well, I would say that the actual challenge is to understand how we introduce that third-party network function inside the existing pipeline, and how we expose those functionalities to the main workload. And by exposing those functionalities through OpenConfig, through an extended YOT model, will completely resolve that specific issue so that we can host on the GPU third-party network functions.
Can you share some document describing these things? Because I'm not, I want to read about it if it's possible.
Well, honestly, that's just an idea. Because I know that with young model, you can completely extend those young models. And by doing that, we could always imagine to have an OpenShift cluster or running on those GPUs. And with an operator to deploy a specific network function, the operator would also be in charge of extending the young models that would be exposed through OpenConfig young data store.
Mm-hmm.
And that way, you have the complete lifecycle management of that network function through the OpenShift cluster, and you expose your additional network functionalities. But of course, that would work for any GPU, not only NVIDIA, but also Marvell and so on and so forth.
Mm-hmm. Oh, okay. Thank you.
I have one other question. So we're always talking about this one cloud use case. There are more hardware vendors here. Do they have any preference for, their top priority use case? Because worked for a hardware vendor before, I always know there is one specific, implementation that we're looking for, or one specific, use case that we're aiming at, and then it will be good to get the second ones. But it would also be good to know here, what will be. Let's say we have an API for different use cases. Which is the one that you guys will work on first? Is it really that use case that we're putting up now, or you have other stuff in the pipeline that you really want this OPI API to work for?
Elko, as a vendor, for example, what I see is interesting in, again, Kubernetes OpenShift. For example, we want to look at the service mesh and offload it to the DPU and provide some APIs. For example, in the service mesh, you want to do some, I don't know, some security, IPsec, and maybe TLS offload, things of this sort. And what I see is the DPU should take the service mesh and offload it from the x86 host. This is what
two comments. First of all, very small one. The IPsec APIs already defined that with Intel and Kyle. You can look at the protobuf definitions, and we also implemented using the strong swan reference implementation example. So it's all on GitHub. I can post the link. So all the IPsec work was almost completed. So you can all look and tap into that. Second is, Elko, this is an excellent question, but I'm not sure that any answer from the DPU vendors is interesting until somebody goes and proposes some implementation. They can all come and say, we don't agree with these use cases, we want to focus on other use cases. That's totally fine. But who is going to define the APIs? Again, we need the working people. We need to stop talking and we need to start implementing. So we need somebody to come up with a protobuf definition or young model definition per Christoph. I don't really mind either one. Vipin is focusing on cloud providers, and he contributed the protobuf definitions for cloud provider use case. If Naftali is very focusing on Kubernetes, Marvell for sure, and we are very welcome in it, can propose a new pull request for separate use case Kubernetes. We can all review it and merge it separately from Vipin cloud use case. Then we can look together into APIs, find the commonalities, and extract them or change them so they become the same if possible, or at least 90–80% common will be defined. So we all welcome in all the contributions, but if somebody is focusing on another use case like Kubernetes, for sure, go ahead, define the protobufs or young models, post them on the pull request on GitHub. We will review and merge it. No problem at all.
Sure, I think just the first step before you do any APIs, you need to like define, solve the use case, and then wrap it with APIs. I think it's like what we're trying to do now, and the API is the second step after you have something working. So what you're saying is like we are a bit far from there, but I think we want to arrive to this point eventually.
Yeah, because for cloud providers, as we said, those are in production, right? Those are not theoretical APIs. Those are in production with cloud providers, specifically for only AMD Pensando, that we want to extend to accommodate Marvell, Intel, and NVIDIA as well. We are willing, obviously, to change all of those APIs to be more common and accommodate all the DP vendors. Things are specific to AMD Pensando, we will remove. So this is why we need people to review it and say that they are okay with that, vote on it, and say, okay, this is OPI API for cloud use case. This proven API is already in production, so we all feel comfortable with that. And do the same work in parallel for Kubernetes. Let's pick Kubernetes networking, either Calico or OpenShift is OVS OVN or whatever we want. Define the protobuf APIs or different type of integration or young model, whatever people feel comfortable. Let's solve that use case and let's move forward with implementation as well.
Yeah, Boris, I fully agree with your approach. Okay, so time is limited for this discussion, but we are willing to provide, and develop those kind of APIs. Okay, and provide the prototypes for those. We need some assistance from defining, the exact, at least the first features to try them out.
What company, Rabbi, you are?
Solid Run.
Oh, sorry. Okay. So Kubernetes APIs, you take in the next item, you can start this discussion, and we're definitely willing to pull in all the relevant people to the discussion, right?
Understood, Boris. Thank you.
Rabbi, so Kubernetes, right?
Yes.
Okay, just making sure. So Naftali, let's start working a new work stream with Rabbi and Naftali and others who are interested in Kubernetes workflow. And let's try to define it. I'm all forward for it. I say we have to solve both use cases.
Yeah, makes sense.
All right. This has been a very good discussion today. I think we've got several different actions that we need to go off and work, one of which is making sure that we can come up with some of these architectural models in parallel to the work that we're currently doing around use cases and making those definitions. So hopefully we'll start seeing a bunch of different contributions as we continue forward in the year, and we can start reviewing those. So thank you everyone for attending. And
so Mark, just to recap,
sure.
I will whoever is interested, Amarcha or whoever is interested on cloud APIs, I'm going to submit a pull request based on the previous those 6 or 7 APIs that Boris was showing for the cloud use case, and then that's something on me. I'll definitely participate in communities as well, but we'll let others lead that use case.
Okay.
Thanks.
Thanks, Vipin.
Mm-hmm.
So we'll meet again next week, continue the different topic discussions as we come up with additional topics, or we can even continue this one. So thanks everyone for attending, and we'll meet again next week.
Thank you.
All right, thank you.
Thanks.
Thank you and Happy New Year. Bye.
Happy New Year.
Happy New Year.
Yeah, same to you guys. Bye-bye.